All right, what'd you get whenever you're working on your own? Let's see. So what I hope to do is confirm all of your correct answers here. So let's take a look at the first one. The first thing that I'm going to do is I'm going to label my sides. So I've got my 39-degree acute angle. The 14 that's directly opposite that is our opposite side. And the X down here at the bottom is touching our angle. This is our adjacent side. I don't need to bother with the hypotenuse. It contributes nothing to the problem. Opposite and adjacent, O over A, another hour is the tangent ratio. What goes inside the tangent ratio is our acute angle measurement, 39 degrees. That should be equal to the opposite side, 14, over our adjacent side, X. So notice that this is one where the variable's on the bottom, which means that the shortcut is just to switch that out with the tangent ratio. So X is equal to 14 divided by the tangent of 39. Calculator time. It says nearest tenth. Got it? Got it. What was I typing in here? 1439. Okay. 14 divided by the tangent of 39-ish degrees to get about 17.3 when I round it. Okay, so notice that this side, this 17.3 for X, it's bigger than the 14, which means that this angle up here, the missing angle, should be bigger than the 39 degrees. All right, so if I take 90, and I subtract the 39, that's almost 40, it'd be 50, 51. And that definitely is true, right? Again, kind of looking at those things adds a little bit of confidence to you and your answers that you're getting. All right, let's look at the next one. Here's my 52-degree angle, and I don't even have the opposite side. Instead, I have this X, which is the adjacent side. Okay, all right, what's going on? What the heck is happening? There we go. And then the 15 there across from the right angle, there's our hypotenuse. Adjacent hypotenuse. Oh, hell, another hour's cosine. So the cosine of my angle measurement is equal to the adjacent side, X, over the hypotenuse side, 15. So this time the variable's on top. I just need to get rid of the 15. I can get rid of the 15 by just multiplying it across. So X is equal to 15 times the cosine of 52. Exact answer. But we don't want the exact. We want the approximate. 15 cosine 52 times cosine 52 degrees. About 9.2, apparently. Now, on this one, as far as comparison goes, it's smaller than the hypotenuse, so that seems reasonable. All right, and then let's do the same kind of thing over here on number 3, our very last one, our very last problem. So in reference to our angle 61, we have our opposite side one more time, opposite. And then we have 17 as our hypotenuse. Opposite hypotenuse, oh hell, that's sine. It's a little bit of sin. 61 is equal to opposite side, X, over hypotenuse side, 17. So now this one's like number 2. All we have to do is multiply that 17 over. X is equal to 17 times the sine of 61 degrees. Calculator time, 17 and 61. 17 times the sine of 61. And getting about 14.9. And again, as far as that goes, it's less than the length of the hypotenuse. So as far as we're concerned, it seems reasonable. All right, that's it. That is going to conclude our lesson here on trig ratios. We were able to discover and use the 3 main trig ratios. And those 3 trig ratios are sine, which is the opposite side over the hypotenuse, cosine, which is adjacent over hypotenuse, and the tangent ratio, which is the opposite over the adjacent.